Taking advantage of the total lunar eclipse of January 2019, astronomers, using NASA's Hubble Space Telescope, have detected ozone in Earth's atmosphere. In this observation, Hubble did not look at Earth directly. Instead, astronomers used the Moon as a mirror to reflect sunlight that passed through Earth's atmosphere. This method serves as a proxy for how they will observe planets around other stars in search for worlds similar to our own. Though numerous ground-based observations of this kind have been done previously, this is the first time ultraviolet light passing through Earth's atmosphere was observed from space. The measurements from this experiment detected the strong spectral fingerprint of ozone. On Earth, photosynthesis over billions of years is responsible for our planet's high oxygen levels and thick ozone layer. That's one reason why scientists think ozone or oxygen could be a sign of life on another planet. But finding ozone on distant worlds isn't an easy task. Ultraviolet observations like this can best be conducted from space telescopes above the limiting effects of looking through Earth's skies because ozone blocks most ultraviolet light from beyond the atmosphere. One of NASA's major goals is to identify habitable and inhabited planets. But how would we know whether a distant planet has ozone or not? The atmospheres of some extrasolar planets can be probed if that distant world passes across the face of its parent star, called a transit. During a transit, starlight filters through the backlit exoplanet's atmosphere. Chemicals in the atmosphere leave their telltale signature by filtering out certain colors of starlight. Astronomers have used Hubble to observe the atmospheres of several gas giant planets that transit their stars, but terrestrial planets are much smaller objects and their atmosphere thinner, like the skin on an apple. Therefore, teasing out these signatures is much more difficult. To prepare for future studies with larger telescopes, astronomers used Hubble to conduct experiments on a much closer and only known inhabited terrestrial planet, Earth. Our planet's perfect alignment with the Sun and Moon during a total lunar eclipse mimics the geometry of a transiting terrestrial planet with its star. But the observations were also challenging because the Moon is very bright and its surface is not a perfect reflector because it is modeled with bright and dark areas. The Moon is also so close to Earth that it appears to move very quickly in the sky, making it harder for Hubble to stay pointed at the same location. However, in spite of the challenges, the experiment was an incredible success, and Hubble is supporting the ongoing quest to find planets that are similar to our own and perhaps, one day, find signs of life on other worlds.